In this video, I'm going to go over half-life problems. In a half-life problem, you have two variables that you're working with. You have an amount of substance, whether it's grams or milligrams or whatever, and you have a length of time. So whenever you're doing one of these problems, you're going to have to either solve for an amount of substance or for a time, and you have to pay attention to the wording. So in this example, sodium 25 was to be used in an experiment, but it took 3.0 minutes to get the sodium from the reactor to the lab. If they started off with 5.00 milligrams out of the reactor, how many milligrams of sodium 25 were placed in the reaction vessel 3 minutes later if the half-life of sodium 25 is 60 seconds? So they are asking you to solve for an amount of substance in this example. And what we have to look at is the half-life I'd have to give you is 60 seconds. So every 60 seconds, half of that sodium 25 has decayed into something else. I want to figure out how many half-life cycles that went through. So I'm going to take the 3 minutes and just make it 180 seconds so we have the same units and divide that by the 60 seconds. And that's telling us that it went through 3 half-life cycles. Now when you're doing this, if you're going to set up a table, make sure you do this initial spot here where I'm going to write initial, or you can write start or some other word of your choosing. But one of the most common mistakes here is not putting something here to go along with the 5.00 milligrams. What I see happen a lot for a common mistake is instead of putting initial here, someone writes number 1, and it makes it seem like you have 5 milligrams after the first cycle, but in reality you have 5 milligrams before it started to decay. So by the time you get to the first cycle, half of that is gone. So if you don't put initial here, if you put 1, you're going to be off by a cycle. So after the first cycle, half of this has decayed into something else. So there's only 2.50 milligrams of sodium 25 left at that point. The second cycle, that will get cut in half again. You have 1.25 milligrams. And then the third cycle, that gets cut in half again. You have 0.625 milligrams. And we know that it went through 3 cycles, so this ends up being the answer. They started off with 5.00 milligrams. After 3 minutes, they only have 0.625 milligrams of that sodium 25 left. That is what ended up going in the reaction vessel. So that is an example of you solving an amount. All right, now this example, how old is a skeleton sample if the current amount of carbon in the bones is 3.125%. Alright, they're giving you an amount here. It's not grams or milligrams or something like that, but it's still representing an amount. Assume you started with 100%. The half-life cycle of carbon-14 is 5,730 years. Alright, so for this one, it is asking us for a length of time. So what we have to do is set up another table. I'll do initial, and we are starting with 100%. Since it didn't give us a mass, we're going to say 100% is at the initial. So after the first cycle, that gets cut to 50%. After the second, it goes to 25%. After the third, you have 12.5. Fourth turns to 6.25%. And pay attention to what you're going to. The problem tells you 3.125%, so that's what we want to work our way down to. So it looks like the fifth cycle is going to bring us to 3.125%. So it went through 5 cycles. Each cycle is 5,730 years. So what you can do is take the 5 cycles, multiply it by 5,730 years, and then that will give you how old the sample is, 28,650 years. So this is an example where we had to solve for the time. I gave you an indication of what you're starting with, 100%, and I told you how much you were ending with, 3.125%. So you had to figure out how many cycles it goes through to get that final amount. And then you just multiply the number of cycles by how much each cycle takes. Remember, put like initial or start or something like this, because if you put 1 up here as 100%, you're going to be off by a cycle in this table, and it's going to throw off your math. One more. The sample carbon-14 has been decaying for 22,920 years and is now 35.0 grams. What was the size of the original sample? The half-life of carbon-14 is 5,730 years. Okay. It is asking for amount. What was the size of the original sample? Now, I give you 2 lengths of time, 22,920 and 5,730 years. So we want to figure out how many cycles that went through. But a key word in this problem is, what was the size of the original sample? That is telling you that you have to work backwards. Because when they checked it after almost 23,000 years, it only had 35.0 grams left. So the original sample had to be more than 35.0 grams, because that's what it is after it went through a certain amount of half-lives. So what you want to do is take the larger length of time, 22,920 years, divided by 5,730 years, and that's going to give you the number 4. It's telling you it went through 4 half-life cycles. So we're going to do this initial, but it's asking for how much was in the original sample. So we're solving for the number that goes there. We know it went through 4 cycles because that's what we calculated. After the 4th cycle, there was 35.0 grams in there. So what we have to do is work backwards to get up to the initial. So you're multiplying by 2. So 35.0 times 2 gives you 70.0 grams. Multiply that by 2, it gives you 140 grams. Multiplied by 2 gives you 280. And when we multiply that, we get 560 grams. And that's how much was originally there. 560 grams after it went through 4 half-life cycles. When they measured it, that's where you get that 35.0. Alright, so remember, there's really 2 variables you work with, amount and length of time. Pay attention to which one you are solving for.